Hello guys, welcome to my channel. Today I want to use an opportunity, take a problem. It could be a financial problem. It could it could come up as a financial problem. It could come up as a statistical problem. But I want to use the problem, as you see in the description, called running totals on Google Sheets. I want to use it as an opportunity to expose or reveal a couple of formulas or functions that are available in Google Sheets, and they could be very helpful in to run some analytics when you combine them. So I would dive straight into it. I have decided to create an hypothetical array of numbers. Um, just Yeah, I could as well use the opportunity to also expose. Now, assuming you want to create an array of numbers, random numbers, maybe just for use. One of the functions that are available in Google Sheet is we call them now. Google Sheet has a couple of functions. We have the array functions, statistical functions, and part of the array functions that you can use to generate random numbers will be rand. Um, you can have the rand between, um, and a host of others. And but in case you want to generate a series of numbers, um, random numbers that you're going to use probably for maybe for a test or for some other um, modeling or simulation. If I want a series of number, another function that does that for me is the rand array. Okay, the rand array will generate a series of number, but the arguments pretty kind of differ, which is going to be like, okay, how many rows of numbers do you want, and then how many columns? So I want one. In this case, I probably choose 50 rows of numbers with just one um, column. This will generate a list of numbers, random numbers between 1 and 10. Okay, but however, because I want them to be between 1 or 0 and 100, then I can choose to use one of the other available array formulas, which is the array formula itself. How funny it is that an array formula is one of the array formulas. So then I take this number and then I multiply it by 100, but just to keep it at rounded number, because I don't want because if we run this, you will see the result. Okay, uh, let me show you the result first of all of the rand array uh, function for us to see the 50 rows of number with random numbers between 0 and 1. So we can see to generate series of numbers between 0 and 1. But simply because we want numbers between 0 and 100, then we bring in our beloved array formula, and then we want to multiply each of these by 100, and then it gives us a series of numbers between 0 and 100. But this isn't beautiful enough. I just want you to put them, all right, round them up to the nearest whole number, and then I would employ the use of the round function, and then I will just put the comma to the nearest number. Uh, there you go. So that is the operation. Then enter. So then it gives me a number that I can as well now highlight, copy, and then Control Shift V is equivalent to when I want to paste the values excluding the formulas. I would use paste values only, come to right click, paste special, and then click on values only, which is equivalent to control plus shift plus V all together. I like to use my control shift V rather. So then the formula is gone. Now I have my array of numbers. So I'm going to delete this first one now that we created this one together. So let me delete this, and then we have our array of numbers. Okay, so assuming I have a task of generating the um, running total of my values. So the running total is the problem. So there are a bit of a couple of options, but I will deal with just two options that I am aware of, and then the first one begins with just a tweak. Now we can use the sum functions, which is pretty much just to run a sum. But the tweak in running the sum function in order to be able to generate a running total depends on what we call expandable ranges, because technically what we want to do is to take that array, and as we go down the array, as we're moving one step, each step further down, we're combining a couple of rows, and then we are adding them up. So essentially, that's my own understanding of the expandable array, and it has a connection with what we call absolute referencing. And take for example, what is absolute referencing? When if I want to refer to a particular cell, let's say I say this is equal to this, that's a C42, C2 is equal to A2. Now, if I drag this down, it's going to go ahead and apply this idea smartly. The computer is going to understand that I'm doing a referencing that is a relative referencing, whereas it's taking C2 to be A2, and then C3 equals A3, then C4 equals A4. So that's relative referencing. But absolute referencing is when I take A2 and then I press F4, or use the $sign before A and then before 2, such that when I drag down the formula, the computer only carries A2, which is the absolute referencing. So now we're going to use this absolute and relative referencing in arriving at a running total, wherein we're going to do a sum function, but however, the argument in the sum function is going to be a combination of both the absolute referencing and the relative referencing, because we want to achieve an expandable range. So, which is going to mean, sum this. So this is where we want to begin the range from, and it's going to expand from here. So we'll lock this down by pressing the F4, and then with the colon, and then the same A2 is where we're going to A2, but without the F4, because this is, we want this to be relative, this to be absolute, so that when we drag the formula down, then it will be an expandable range that is being summed up. And let's see the result of this. Even, can you see that Excel Google Sheet is smart to make suggestions if you want to apply this to the other rows? And yes, we want to. So there we find that 47 is 40 is plus 3 is 50. But then can you see the absolute referencing and the relative referencing in action? So we have the absolute. So as we go down, we begin to see that the starting point remains the same, but we're expanding the range. Kudos to Mr. Excel in fun. Excel is fun. You can check him out on YouTube. He has very lovely videos on very many solutions in Excel, which are pretty much are available in Google Sheets as well. I learned a lot from that guy. So now this is the first solution, pretty much. But now we observed that we needed to manually, even though Google Sheets suggested this to us to expand it down. But what if we had 250,000 rows of data? Yeah, Excel would drag it down, but to avoid the manual dragging down, I mentioned earlier that Google Sheet also has what we call array functions. Array functions are powerful. All right. Now we have, I mentioned earlier, the rand array, the array formula itself. We have map. We have the by row function, by call function, choose call function. So now in a situation where we want to be dynamic and then just put the formula just in one cell up here, I'm going to demonstrate with uh, this in another column. So running total method 1 and then running total method 2. So this is where I'm going to expose a couple of other functions that are available, and I believe they are helpful in carrying out even beyond the running total. I'm just taking the running total as an example. We could have some other statistical analytics or financial analytics or operational analytics, whatever the case is. So now I'm going to, by way of digression, but in preparation for the solution, to explain a couple of other how some of these formulas I'm going to combine, how they work. First of all, I know that might be, I don't know who is watching the video. We might have those who are just beginners, those who are, we could have advanced, we could have intermediate, whatever the case is. But in case we have some beginners, so I just want to explain some of the functions that I will be making use of. One of them is, like I said, the array formulas, but the example that I want to be combining to produce a solution is one of the one that is called the map function. Okay, so the map function allows us to take in an array, okay, and then run some operations as we desire. In some later videos, I know for data analyst, a dates table is pretty much one of the things that you use a lot in developing data models. And I know maybe we have those who use Power BI, Power Query in the audience. I would be doing in some later videos how you create a date table with some of these array functions in Google Sheets with with a combination of other functions to generate the date table. So now, but just to begin with, so this map function takes in an array and then gives you the power to run some operations on the values contained in that array. All right, so just to explain the arguments. Now, one thing that helps me to understand any function in any programming language or even in Google Sheets is pretty much, first, if it's a function, it must definitely have its syntax, the number of arguments that are required. All right, so once I'm first of all going to, once I'm able to understand the syntax, excuse me, or say the number of arguments, the structure of the arguments in that formula or function, I then can begin to master the function. So obviously the map function takes in 2 or 3 blocks of arguments. The first one would definitely be the arrays you want to operate on, which you can call variables. But in when we're in the data, in the data world or even in the computer world, variables are temporary storage, or they could be permanent depending, but it's a storage where we provide and then we assign values, we store values in. So, but the type of values that you can store in a particular variable is now, determined or can be explained in the world of data types. You can store a text, you can store an array, you can store numbers, integers, floats, whatever the case is. So, but the map function takes in an array or arrays, but one thing the map function likes a lot is to ensure that the array size that you're going to put in the, put together, the array sizes must be the same. So it can take multiple arrays depending on the operation you want to carry out. So you put the array first of all, and then it must be followed by the lambda function. So the lambda function is wherein you're going to name each of the array that you have put in the map function, and then these names you've given to these arrays will then be what you use as input that follows the operation. So let me go over it again. You put in your array variables. So because essentially the map function and other array functions in Google Sheets, they help you loop through, the values in a particular array. It could be one-dimensional array, it could be two-dimensional array, or multi-dimensional arrays. So you can loop through each of these arrays using this map functions and carry out desired operations. So you put in your array or arrays. I'm going to remove them, just explaining, and then the names of your array, name or names of your array, and then your operations, operation or function, the real operation you want to carry out over the arrays, operations over the array that you have, or arrays, whatever the case is, as it were. So, but now, let me do an example. Assuming I want to take a series of arrays like the one we have even just created. Okay, I can take that array. I can take the array from here. Okay, I'm just interested in a couple of rows of the arrays. I take the array, and then I have my lambda function, and then I name my array each, just for easy understanding. And I'm saying, what do I want to do with each of the values in this array? So if I want to multiply by 2, I can say, okay, I want to multiply each by 2. So give me each. Okay. And then what will be the result? It will give me an array that multiplies each of these value by 2. I can do a couple of other complex analytics or complex operations on the array. So assuming I wanted to generate a times table, for example, we could go ahead and let me use the opportunity to also introduce a function in it's called the sequence function. I love this function so much. So I can nest this array, all right, in this and say I want a sequence of 1 to 10. And how do I generate a sequence of 1 to 10? Just the syntax of the sequence. So how many rows do I want? I want 10 rows of numbers. Okay, how many columns? It's just one column. And then where would I start from? I want to start from 1 and then stop, then increment by 1. So what have I done? I have created a sequence of numbers, and then I'm going to conduct an operation. So this sequence is going to be an array of 1 to 10, and then the operation I want to carry out on that array is to multiply each value in that array by 2 so that I can have the 2 times table. So this gives me 2 times 1, 2 times 2, 2 times 3, 2 times 4, 2 times 5, 2 times 6, 2 times 7, 2 times 8, 2 times 9, and 2 times 10. And assuming I want to make this 2 times, I want to make the table visual. What am I really multiplying by 2? Oh, I want it visual. Then this will make me introduce a powerful function called the let function. Okay, that gives me more flexibility. Okay, so before I do that, an alternative way of generating, okay, this revealing the table that I've just multiplied by 2 could be, okay, this is an array. All right, this is first an array on its own, this is another array on its own. Okay, so I could literally use a method of creating arrays as well in Google Sheets, that is with the use of curly braces. Okay, so what am I going to do? I want to do what? I want to create a table that has 2 columns. So a trick is to use the curly braces. In Excel, we have some other functions, but in Google Sheets, this is how you get it done. So curly braces, all right. Now, we have some punctuations we can use within the curly braces to indicate the number of columns that we want in the table or array that we're trying to create. When you use the comma, the number of times you use the comma, or you can use the comma to indicate the columns. While if you have just one column, or you have 2 tables that you want to stack on top of each other, the separator then will be the semicolon. We'll get to the semicolon if possible in this. I don't want to make this video too long, and I'm probably going too long on the video. So let's go straight and just display the table, the number table from 1 to 10. It's going to be here. And as well, what is the result? We actually multiplied by 2, which is also an array. So for emphasis sake, when you use an array function, obviously you use the array function to carry out an operation on an array, and then the output is always an array. So we have an array here by the side, and then what do we get? We get our number and then the multiplication by 2. So now how does this help us with the with the running total? I just wanted to set the ground rolling and it's getting too long. Okay, so we're going to come here where we're going to use, I was going to introduce the let function. So let me gradually introduce the let function, which is a powerful function in Google Sheets that helps you enter the world of something close to programming, essentially, where you can declare variables, carry out multiple operations, and yet you produce only one result, one output. So if I have complex operations I want to carry out using multiple variables, virtual tables, we use virtual tables in the world of data analytics. So for those who use functions like Excel, or SQL, so virtual tables, and then a couple of other things. So now I am going to take an array. So I'm going to first of all, the approach I want to use to be dynamic right here is pretty much, I'll be using another function called offset. So what offset does for me, okay, the offset function, I'll combine it all together with the let function in a bit. So the offset function, let me explain. Offset is like a slicer, all right? I'm sure that will be familiar to data analysts in the world of when you want to slice a particular table, not the slicer in the sense of filters in pivot tables, but a slicer in trying to slice tables in different maybe you just want to select a portion of a table. So as only we want to slice, we can slice in as many dimensions we want. So the offset function helps us to slice. Take for example, this is a table right here. We have a table of one column, and if we want to consider A and B, we probably have two columns. So if I want to take A and B as a table, and I just want to slice just to give me the first column and just a few rows in that column. So I have to give it a reference, all right, beginning from here, all right. And then what is the other argument? So how do you move away from the reference in terms of where do you want to start from? An address. So the first two arguments are pretty much like the address, where to start from. So the other two arguments are pretty much all other there are other two arguments within the 5 arguments that goes into the offset function that are optional, but the first 3 are pretty much, are standard. So you have to give the reference, which in combination with the 2 other arguments are only telling the address of where to start from. So A1 is a reference, and then, but my address is not completed until I tell it, okay, take the A1 as a reference. Then where you're going to begin from is you're going to move to row. How many rows should you move to start from, and how many columns do you move to start from? All right, so because we're starting from just the reference, so we're not moving anywhere, we're staying at where we are, we're starting from there. But then the 2 other arguments, now how many rows and how many columns? So how many rows will be the height, and how many columns will be the width? So we're saying we want to grab the information in A and B. So we're going to grab 5 rows. Let's say we want to grab 5 rows from the first column, but we're grabbing the 2 columns. So 5 rows, and then we're grabbing the 2 columns, and then there you go. So the offset function gives us a slice of this whole table, but that doesn't yet solve our problem. So what we want to do is a second approach to the running total. Okay, so now I begin with the solution. All right, so I want to use the let function. Okay, I'm going to use demonstrate the let function. I said it can help you store variables just to give you some more flexibility around the operation. So I'm going to use the offset function, but I want to store my reference in a variable called reference, and my reference is going to be right here. That's where the array starts from. Lock it down. One beautiful thing with the let function is that it's like you're creating a constant variable. So whether if I apply the absolute referencing or not, it's going to pretty much store it in the reference, and every time I use the reference variable in any other operation, it's going to give me my result. So the argument or the structure of the let function is you define your variables, and then you tell it the result to output, and then the result that you want it to output could be calling on an existing variable, or you can actually output an operation on its own. Take for example, assuming I've stored this variable reference, all right, I'm still using the let function. I can say, okay, still give me what is it that is in the ref function, the ref variable rather. So then it gives me 47, but I'm still at liberty to say output 2, and then it still gives me 2. Okay, and I could as well carry out another operation and say reference multiplied by 2 of reference. I have to make sure I typed it right. So it gives me 94. So this is the liberty that the let function gives to you. Okay, so but now onto the solution of our running total. So okay, I am going to store the reference in the variable, and then go on to start I'm going to use the map function to essentially solve my running total problem, which is going to be, I want you to take another variable, which is my array, the array of values, just giving it a name to help me understand what I'm saying. So I'm grabbing, I can grab the whole column. I would introduce another function that helps me constrain the values I'm grabbing to exclude anything empty. So I'm grabbing everything right from A2 down to wherever there is a value, assuming there will be future rows added to my array. So I've stored that value right there. Another variable, so I've stored the value in this variable. So I want to add another variable, which is probably going to be useful as we go. So I want to count the non-empty rows in this array. So, and how I get to that, the nonNull, would be to use the count a function in Google Sheets. This is function that counts the non-empty. So it's going to count the non-empty in the array of values. Okay, so let's proceed. So now I've said I'm going to use the map function to solve my problem. So I also want to store the result into what we say, let's call it result, our running total, or let's call it the running total. So we're going to store the operation we're going to use to solve the problem. We're going to store it in the running total variable. So map, I'm going to take the array of values, and then what follows is my lambda function. Remember the syntax, and then I'm going to call it each, remember, and then, so what do I want to do? So what I want to do with this is this. Okay, I want the offset function. Remember, the solution was pretty much the solution in the first option in solution was like creating an expandable range. Okay, so I'm going to use the offset function to create an expandable range. So I'm using the offset function to begin from my reference position. Then how many rows do we want to offset? All right, I'm not moving. I'm starting from just from the reference, since I've made it A2. So what is then the height? So this is the height, where it is inside the height argument that I'm going to introduce the expandable function. And how do I introduce that will be through another function called row. All right, so this row function is to check the row of a particular, the position of a particular value in a range. All right, so, and remember, the each is leading us back to the values in each of the array values. So I'm grabbing, let me call it each value. So the row function for me is going to check the row position as a number and return a number. And then as we move down, the number is going to be changing, and that will create my expandable range. And yet I'm working within one column. Okay, so that is the offset. The offset will grab those values for me. Okay, just for us to kind of see what the offset function grabs, I'm going to take a step and let's just see, just to show. Now the offset function will return a row. We return values that are in rows. Okay, so but because I really want us to show, I'm just going to transpose the values that is going to give unto us, close parenthesis, and let us show what is stored in the running total. All right, show what is running total, close parenthesis. All right, so L2, so what is in L2? Okay, so let's show just for a few rows, because there's some, okay, there's some columns, and let's delete everything that is here then. So okay, so can you see that this is pretty much showing us as it's going down, it's grabbed 47 and 3, on the next row it grabbed 47, 3 and 59, and then 47, 3, 59 and 31. and then on and on and on like that. But we don't need it to show them. We need it to sum them up. And then I'll just replace the transpose function with the sum function to achieve our running total. And then let's do enter. And then what is the result? Can we see the running total is 47. So something seems to be like a problem, which is now we have the running total starting at the first row, or rather starting with the um, what's supposed to be on the second row. So how to fix that is pretty much just by offsetting this, because this is checking the row or the row of our value based on this column, and then it realizes that the first one is 2, so we is using the value 2 right here. So we want it to start from 1 and then go on and offset that. So that pretty much is just putting -1 at the end will fix that, and then it goes on and on. So the second problem which I want you to observe is, now because we're using an array formula, and then because our range is pretty much the whole column, so it's just going on its own to run the formula beyond where we have numbers. So there are two ways to take care of that, which will be, first, we can decide to limit it by limiting it to the last row in the column, which is row 51. By the way, I'm moving up and down with control down arrow and the up arrow, which makes moving around arrays or table pretty much fast. So that fixes it. All right, fixes it. But another way to kind of fix that will be to use another array formula, which is used to constrain the operation that we have put here. So we want it to output this, but under some constraint function. So, and the formula that does that, the function that does that rather, is the array constraint function, which takes the table you want to constrain as the first argument, the number of rows you want to display, which is pretty much the non-null rows, which is the one we grabbed here, and then the number of columns that you want to show. And in this case, we have only one column, but if it were to be more than one column, you can use the columns function, which will give you the number of columns. So we're creating something dynamic right here. So which goes ahead, array constraints, so columns, array constraint, my bad, I should spell constraint correctly next time. All right, so that does it for us. And then that's the running total formula. Thank you very much for spending time to watch this video. It's pretty much a long video, I apologize, but I do hope you find the content useful in your day-to-day transaction. And if you have better ways, or you think you have some idea that could be useful as well, feel free to share them in the comment section, and I'll appreciate it. Like, subscribe, and share this video with your colleagues that you believe might find them useful, and then for the algorithm to know that this is of value. Thank you very much once again, and see you in the next one.